one-dimensional motion. So what is one-dimensional motion and what is scalar and vector and what is the displacement, position, velocity, acceleration, time. So these are all things we are going to see that one-dimensional motion. You can take the x-axis. So one side of the x-axis is a positive, that is x. That another one side is a x dash, that is negative direction. So it's a number line, can give that from 0 to one side is a positive, that another side is a negative. So you can give a number like that from 0 to the positive and then negative value on both sides. So the particle is moving in a straight line. The type of motion is called rectilinear motion. That is, you know that. So now we are going to learn the one-dimensional motion. One-dimensional motion, that is particle moving on only one axis. Next one is the two-dimensional motion. Two-dimensional motion means the particles are moving in a two dimensions, two axes. It's using the two axes, x-axis, y-axis. The type of motions are called two-dimensional motion. The particle is moving along a curved path in a plane. That's called a two-dimensional motion. So we can represent that two-dimensional motion in a vector. And we have to know what is the difference between scalar and vector. Scalars have only, it has the magnitude, does not have any direction. Example for this is a one stone. The weight of the stone is, you can take that is 10 kilogram. So the mass of an object is 10 kilogram. So it's a scalar quantity. It does not have any direction. So you can take the another one example for the scalar. Suppose you are drawing line from A to B. The distance between the point A and B is 20 centimeter. So here it has only magnitude. There is no direction. The temperature, when you are measuring the body temperature, it gives a magnitude 98.6 Fahrenheit. So it has only magnitude, does not have any direction. So these quantities are called scalar because it has only magnitude, does not have any direction. So it's called scalar quantities. Here the scalar quantities are mass, distance and temperature. Right? So these are the examples for the scalar quantities. So now we are going to see the operations on scalars. So by using that scalars, we can do that ordinary arithmetic calculation, addition, subtraction, multiplication and division. Here we are going to add the two vectors, that is triangle law of vectors. Another one is parallelogram law of vectors. So first one multiplication, we are going to multiply the two vectors and we are going to add the two vectors, that is addition and subtraction of the vectors. In multiplication of the vector, you can multiply the two vectors. Vector has the magnitude and the direction. See that first one is the direction into lambda. Lambda is the magnitude. When you multiply that, you will get the same direction and magnitude. So that is a vector quantity. So direction and the magnitude. When you multiply the scalar into vector, you will get the vector quantity lambda p, and it has the same direction. That is positive number. You are multiplying that, the direction of the vector is positive. That's why you get positive number. Right? The example for this one is vector, that is direction into that 4 is a magnitude. So multiply with that direction, you will get that 4p vector. So it's the example for the vector multiplication. We are multiplying the vector. So multiplication of vector, another thing is, so you can multiply the direction with the negative number. Scalar is a negative number, the magnitude has negative number. So you will get that opposite direction. See that arrow mark is in the opposite direction. It is indicating that the arrow mark in the opposite direction is a negative vector. So lambda p has the minus lambda into that magnitude of the p. You can get that negative value. Example for that, multiplication of vector, p vector into negative minus 3, you will get minus 3p. Then vector is also in a opposite direction. So this is called a negative vector. So that value is less than 0. The negative value. Okay. So dimension for the vector, that is m equal to m. Right. This is one example for the dimension of vector. The multiplication over. Now we can see that addition. Then how to add the two vectors? Now we are going to see that addition of vectors. Now we can add the two vectors. So the graphical method of two vectors, triangle law of vectors and parallelogram law of vectors. So these are the two additions of two vectors. So these are the very important questions. Parallelogram law of vectors and triangle law of vectors. So in this, first we are going to see the triangle law of vectors. In graphical method, you can take the two vectors, p vector and q vector. That arrow mark is indicating the direction and the length of the line is indicating the magnitude. So AB, that is taken as a p vector. Always in addition, you have to add that, or you have to join the tail of the one vector to the head of the another vector. So A point is a tail and B is a head of that vector, that is p vector. Now you are adding the q vector. The tail of the q vector is connected to the head of the p vector. So BC, you are adding the q vector with the p vector. So that is the method of adding the two vectors. So we are adding the two vectors like this. Tail of the q vector is connected to the head of the p vector at the point B. So the line joining of point from A to C gives the resultant of q vector. That means when you are adding the two vectors, you will get the final result, the total magnitude. That magnitude is R. So you are adding p vector plus q vector, you will get the resultant vector R vector. So DE, you can take that another one vector, that is the resultant vector. You get that from the addition of the two vectors. So P plus Q, you will give the R vector. So suppose we are multiplying, you can add the tail of the P vector also, you can add the head of the Q vector. This is another one method, that's all. So you can say that always we have to add that the tail of the larger vector with the small vector. No, it is not necessary. You can add the head of the greater vector with the small vector, tail of the small vector. So it's also that another method of adding the two vectors. So that is the resultant R. Okay, but it is in the opposite direction. That is, we can multiply by q into p. So it is a commutative property. So vector addition is satisfy the commutative property. So p plus q is equal to q plus p. Okay, so it gives the commutative properties of the two vectors. That is adding the two vectors. So p plus q equal to r or q plus p equal to r. So this is the commutative property of the addition of the two vectors. So whatever you can add, you will get the resultant vectors are same. So you can get the two equations. Then graphical method of vector addition. So you can consider that A vector and B vector and this is C vector. So are adding the three vectors. So A, B and the line joining of that other vector. And the diagonal is negative. So this type of vectors are called, this method is called the parallelogram law of vectors. And this is called the triangle law of vectors. So like a triangle, that's called a parallel. This is like a parallelogram. So that parallelogram has the two triangles. See that? So you can calculate the vector. You can get that addition of the two other side of the vector will give the resultant vector. So it can prove the commutative property and addition property of the vectors. So these are all the two vectors, same magnitude, opposite direction. This type of vectors are called opposite vectors. So when you are adding the two opposite vectors, anti-parallel vectors, you will get 0. So two anti-parallel vectors and magnitudes are equal. When you are adding the two vectors, you will get 0. That 0 is called a null vector or it is called 0 vector. That is, we will get only one point. That is that point is called null vector or 0 vector. Here two vectors are having the same magnitude, opposite in direction. The type of vectors are called anti-parallel vector. So A plus 0 equal to A or lambda into 0 becomes 0. You are multiplying that two values, you get 0. So A and A is in the opposite direction and equal magnitude. So it's a graphical method of vector addition. So you can see that point O and P. So the line joining of the point OP will give the vector R. That T, OT is the vector. I can see that another one position T dash, the time period is T dash. At time T is P, T dash is a P dash is a new position. So indicating the position from O to P dash, that distance we can take R dash. Okay, so that is T to a double dash means the distance between the 2 points P and P dash. We can calculate the displacement between the P and P dash. The total displacement becomes 0. So after returning that point again, it is P position. See that this is the distance between the two positions P and P dash for the time period T and T dash. After T double dash, it return back to the previous position, so the displacement becomes 0. Then you know that what is the difference between displacement distance. Now you are going to see the parallelogram law of vectors. In parallelogram law of vectors, you can take the two vectors A vector and B vector. A vector and B vector is placed to adjacent side of the parallelogram. The resultant vector which is passing through the common tail of the two vectors will give the resultant of these two vectors. So you are taking that A vector and B vector parallelly, you can take the same magnitude. So you can get the parallelogram. The resultant vector will give the green color line. So that is the resultant vector. The resultant vector is passing through the common tail of the two vectors. So A plus B equal to R. So addition of the vectors and subtraction. And it's like look like a ordinary algebraic calculation. You can do like that. So subtract of two vectors. So you can see the two vectors A vector and B vector. They are opposite in direction and magnitudes are different. The magnitude of the B vector is greater than the magnitude of A vector. See that length is greater. So here the B vector has the same magnitude but in the opposite direction. So we can add the two vectors, we can get the ordinary algebraic form. Like we can get the resultant vector. Right? So these are the methods of vectors calculation, addition, subtraction, multiplication. Like that we can do, you are using the different type of vectors. So it's a parallelogram law of vectors. And now we are going to see the addition of two vectors in analytical method, vector algebra. So how we can add the two-dimensional and the three-dimensional vector. So we are going to see that in a graphical method. So you can able to see that in graphical method in three-dimensional picture and two-dimensional picture, how to add the two vectors. So first you are going to see that at two-dimensional, in two-dimensional, that x, y, z axis are there, that is called Cartesian coordinate axis. That Cartesian coordinate axis, that x-axis you can indicate the direction, that is I, y-axis it is j, z-axis the direction of the vector is k. That vector unit the teachers will teach you in mathematics, vector 1 unit. So these three I, j, k are the three direction vectors of x, y, z coordinate axis. So in that axis, how you are going to define the position of the points and how to add the two vectors. So that is the thing we are going to see there.